Last session, we seen rectangular ramp supersonic intake system of a ramjet engine. Last session, we modeled only the rectangular, or we may be called as a ramps supersonic intake system of a ramjet engine. So today we will try to simulate that one. So before that, we will try to open our modeled supersonic intake system, so which is available in the geometry of fluid flow fluent. So this is the geometry we modeled in the last session. So we drawn a sketch. If any open ends are there, we will try to rectify here itself. I think there are no open ends. First I will hide the surface. I will check any open ends are there. I will be verifying. There are no open ends are there. Okay, it is not a big issue. Okay, now no open ends are there. So I will again go to surface, show body. I will make sure that surface body is made as a fluid. Okay, this is my geometry is over. Again, I will click on generate. So this is my rectangular or ramp supersonic intake system of a ramjet engine. Here we have a three ramps will be there. One, two, three. There. We will close this geometry window. We will try to continue with the mesh go of the supersonic intake system. So geometry window was given tick mark. So I will try to open mesh window. When I double click on mesh, so it is asking me to update. So I will click on yes. When you're drawing first time, it won't ask any update. It will open a fresh window. Because I tried here once, so for that reason it is asking me to update. So this is our meshing window. So here what I will try to do, I will go to mesh. In mesh, I have a element size. So I'll be giving element size is 0.01 meters. You can see the units are meters here. So I will right click on mesh and click on generate mesh. So meshing will take more time because I given element size is 1 into 10 power minus 2 meters. So each element have a length is 1 into 10 power minus 2 meters. Now meshing is completed. If you see, so very fine mesh it was generated. Most of the elements are quadrilateral only. Okay, so you can see at the bottom we have a statistics. We can identify these many nodes and these many elements it was generated with a 0.01 meters element length. The next step we will try to create named selections. For that reason, at the top I have a edge selection option. I will go to edge selection, then I will select this left portion as a edge. Right click here, create named selections. I will be giving name as a inlet. Okay. Next, I will go to again edge selection. This is my okay. With the help of pan, I will try to adjust into convenient way. Okay. So edge selection. So this is my first edge. Press Control button. Select second edge. Now I will right click it here. Create named selection. So this is my outlet now. Okay. Next one, I will be creating axis. Again, I will go to edge selection. This bottom is my axis. Right click here, create named selection. This is my axis now. Okay. So axis also created. Then I will try to have a wall section. So I will go to edge selection. Top one is my wall and I will zoom with control button. I will select, okay, I will use pan. Okay, I will go to again edge selection with control button. I will select this is my first wall, second wall, third wall, fourth edge, fifth edge. So bottom ramps I selected properly. Now I will zoom to cowl. So this is cowl bottom surface and cowl upper surface. Okay, the inclined line which is joining the upper and lower. So this is how I will select it. The green color says it is selection. At the top also it was selected. You can clearly see. Okay, with the help of pan and control button, I will be zooming and zooming out. So at the top also it was selected, and at the bottom also the green colors they are selected. So that means total I have a edges are there. I will right click it here, create named selection. I will be giving name as a wall and OK. Okay, now I will verify whether whatever named selections I given properly or not. I will go with the inlet. Okay, it was given properly. So this is my outlet and this is axis. Okay, and wall. Okay, all these are mentioned properly or not. I will be verifying. So all these named selections are okay. There. So again, I will right click on mesh and update this one. So the meshing part is over and the named selections are over. Then I will close the meshing window. So mesh was updated properly. Now my next step is I will be opening my setup window. Now this is my setup window. Here left side I have a general tab. There I will be selecting solver type is a density based and velocity formulation is absolute, time is steady, and I will be selecting axis symmetric because I mentioned this one is axis now. So these are the things I will make sure that it was selected. Then I will be owning energy equation. So my energy equation should be given tick mark. Okay. Then in viscosity, I will try to select inviscid flow. Okay. So I will be going to make sure that the fluid flow phenomena is inviscid flow. Okay. Then I will go to materials. Here I have a fluid. I have a air. I will make sure that the fluid is defined here properly. If whatever surface it is there, so whatever surface it is there, along the surface the air should be flows. So that means air should be selected properly or not, and make sure that density should be ideal gas. The default there are other values are there. We will make sure that the density value should be ideal gas. Then after that we have a solids. So it is default is aluminum. It's not a big issue. After materials, then we'll try directly go to cell zone condition. In cell zone condition, we have a fluid and surface body. Here we will make sure that it was given as a air because whatever surface we defined that is predefined. So at suppose if I take t time equal to 0 at that condition, whatever surface is there that will be defining as a air only. Then we'll directly go to boundary condition. In here we have a axis. So the type of axis should be axis only. Then inlet. Here you see inlet. We'll select pressure far field. Then we'll try to edit this one. Here I will be giving Mach number 3.5 and the pressure value 820000. Okay, so whatever supersonic intake system we designed that will be suitable for a intake pressure of 8.2 bar, that is 820000 pascals. So this is our Mach number. We have a constant temperature 300 Kelvin. Apply, close. Then interior surface should be interior only. Okay. Outlet should be pressure outlet. Then we have gauge pressure. I will be changing into So gauge pressure should be 656,000 Pascal. So this will be attained with a pressure recovery. So if you can use pressure recovery ratio 0.8, 0.7, according to that pressure recovery, you will be choosing inlet and exit pressure. One pressure you will be fixing, so will be fixed inlet pressure, which is 8.2 bar. According to pressure recovery, I will be obtaining the outlet pressure 656,000. Then temperature should be 300. Okay, apply and close. Then wall should be defined as a wall only. Okay. Then you see operating condition, it was mentioned as a 0. Then after this one, boundary conditions are over. Directly we go to, uh, we will check control methods. So here we will see second order is there. Okay. Okay, we need not to change. So we need second order for the flow. And directly we'll go to initialization. In initialization, we'll go with a standard initialization and compute from the inlet. We click on initialize. So initialization taking place. Okay, don't worry about this thing because so in previous sessions, whatever setup I use, same setup I will be using. For that reason, in previous setup, I have a line was created, a slotting was created. So there I have a name. So that is some error is showing. It's not a big issue for this case. Then I will go with a run calculation. Then I will click on calculate. So iteration it will take. If you okay, calculation is completed. Okay, so it was completed around 170 iterations. Actually given 500 iteration, but solution was converged before 500. So this will happen. So here I will try to see a contour. So previous contour I will try to delete first. Then I will be select double click on the contour. Then I will select axis, inlet, interior surface, outlet, and wall. Because lines 5 not yet created, so it is previous setup file. For that reason, it is storing those values. Don't bother. You select axis, inlet, outlet, and wall. Then click on compute. Then save and display. You can see. You can clearly visualize there are shocks waves are generated from this ramp and they are reflecting inside and they are leaving as a highest pressure recovery. Okay, we will try to see velocity contours also, compute and save and display. So this is you can see velocity contour. So we have a highest velocity because at the starting we can have a 3.5 Mach number, that is highest velocity. The velocity is decreasing such that the pressure will increase. So not only we see velocity, we will see Mach number also. Okay, you can see we have a 3.5 Mach number to 1.5 Mach number. So we reached to 1.5 Mach number. So this is how we can see uh, the contours of uh, rectangular supersonic intake system of a ramjet engine. I will be closing this setup window. See, this is the issue. Actually, use settings changes for current and future calculation. That means whatever values we are storing, so these will be saved and it will be given some error if we are missing the geometries, some of the geometries. Okay, but your case it's not a big issue. So you start with a fresh file. So there will be no issue with you. Okay, so I will be closing setup window. Now solution is not yet updated. We simply right click here and then we click on update. So it will update the solution. After updating solution, we will try to visualize the result for our geometry. solution was updated. Okay, it was given a tick mark. So next, finally, we try to see result. So we'll double click on result. We'll try to visualize our result window. So this is result window. So we will try to see this is our geometry. Okay, in the left side we have a periodic one. If I select periodic one, a surface was selected. Left surface was selected. I want to see contours onto this periodic one. So at the top I have a contour session. So I will select contour. Okay. Then I will go with a location. I don't select axis. I will go with a periodic one. Okay. Now we'll see variable is pressure. I will be using number of contours are 500. Then I click on apply. So I can able to see pressure contours. You can see in setup window we are unable to see clearly, but here we can clearly visualize. This is our first ramp. From first ramp, a oblique shock was generated. You can clearly see. So this is our first ramp where oblique shock was generated. So this is our second ramp. Here also oblique shock was generated. And this is our third ramp. It is also generates oblique shock. These three oblique shocks are will be going to touch at this point and then they are reflecting. You can see this is the reflection of oblique shock. This is reflecting. So it is continuously reflecting inside and it should ends with a normal shock. Okay, if you are not able to identify, normal shock means perpendicular. Okay, you can see here this shock is inclined one. Okay, at the exit we need to obtain the normal shock. If you are not able to get normal shock at here, you will extend this one. And also you can make sure that this shock, this oblique shocks also deviating from this cowl tip. So that means exactly this oblique shock to touches the cowl tip. So that we will make sure and we will adjust the ramp 1, ramp 2, ramp 3 angles and the position and the distance between the first ramp to this cowl tip. These dimensions we will try to change. Then I will see velocity contour. You can see the velocity contours will be generating. You can see this is our velocity contours. Now I will try to visualize the streamline here. So for that reason at the top I have a streamline option. Then I will start my streamline with the inlet. Okay. Then I have a number of points, that is streamline points are 500. I will go with a forward and backward direction. Click on apply. I can able to see streamline. So but I'm unable to visualize clearly here streamline because actually at the starting I was on my periodic one. Try to I will off now periodic one. Now you can see these are the streamlines we can clearly visualize. Now what I will try to do, I will go here video animation, then I will select streamline one. I will make it somewhat slower, then I will run this one. This is how you can visualize your fluid flow. Okay. So fluid is okay, you can see here fluid is changing its direction. Okay, so this is how we can clearly visualize. Okay, this finishes our simulation of rectangular or ramp supersonic intake system of a ramjet engine. Next session, we will try to see bleeding process of rectangular supersonic intake system of a ramjet engine. Thank you.